Okay, I think we can start now. Hello and welcome everyone to the next part of our Kubernetes 101 webinar series. My name is Caroline and I'm happy to see that you're joining tonight to learn more about keeping the state of apps part 2. Our speaker for today's webinar is Frank, who works as a solution engineer at Kubermatic and who will be explaining you how to use simple volumes inside your pods, what types of volumes are available, and how storage classes help to make the process more dynamic. As always, if you have any questions during the presentation, please use the Q&A chat window below so that we either can answer them straight away or in the Q&A session right after the talk. And one more note to make before I hand over to Frank, in case you need to drop out earlier, no worries, we are recording the session and we will send out the replay in the coming days so that you can watch the session whenever it suits you. Yeah, that's it from my side. I hope you'll enjoy it, have fun, and Frank, now the stage is yours.
Yes, hello. Let me welcome you too from the wonderful Oldenburg here in the northwestern of Germany. Today a bit of gray and cold and wet, so it's good to stay inside, not only today, but especially. Yeah, as Caro said, I'm a solution engineer and at Kubermatic, working inside the professional services team, and where we do services for our customers and help them to install and to maintain their Kubermatic and to their Kubernetes. I'm a pretty oldie, more than 30 years in business, focused mainly on development topics. For example, here at Kubernetes, Kubermatic for operator development. And I'm also author and speaker at different conferences. So the topic of today, as Caro has said, we talk about persistence, about first a little step out to databases, but then mainly about volumes, which are part of the Kubernetes way to store data. Persistent volumes, which is a special helping type for it. You would see the difference. The persistent volume claims, which then are needed when we have persistent volumes, or the storage classes, which are a way to provide persistent volume claims more simple to the user, more dynamically, more simple, and so that you easily can drop the knowledge of the first part, but have then the better way. So first little step to the to databases. You know, most applications need some kind. It's if we do accounting, ERP, CRM, billing, payroll. Every time we work with microservices in business applications, we have some kind of databases, but also technical applications need databases. So how to handle these inside of Kubernetes? That is, one very simple way. We run a database outside the cluster and use the ways on have it. For example, if there's a need, high available, if it's scalable, but it simply is not part of the cluster. But that's not what we want. Very often in simple cluster, that helps. But we also can make the database run inside the cluster. So therefore, for many typical RDBs are solutions that are working inside of clusters. Here we take, for example, MySQL, but also PostgreSQL. There's no problem to get the according pod specs or even operator, which are able to set up high available Postgres installations inside a cluster. That's really nice. So that you have the benefit of your cluster even for databases. And there's also a group of large, scalable, cluster native databases using sharding for the data, and like Cassandra or Riot, they are intended to be scaling in cloud environments and in cluster environments. So these databases even run better inside of clusters. But these databases are not the main topic today, so let us quickly rush into the topic volumes. Volumes. Yeah, I think most of you already know volumes from containers, from Dockers. So a container typically has an internal kind of file system. It's just a simple file system, but this file system isn't really persistent. It's volatile. And if you want to allow your application inside the container to write data in a way that can be used after a restart, for example, you can create volumes and then mount host file systems to your internal file system, so or directories of the whole file system. So there are ways to create volumes inside of Docker, but also you can say this directory on my computer is that directory inside the Docker container. And this is a mechanism that is also used by pods inside of Kubernetes. So they are bound to the life cycle of the pod. So it's that the volume itself is provided by Kubernetes, but they are bound to the pod. Look to them, yeah, as some kind of directories. They can, like you can share one volume to many containers or many applications inside of a container in Docker. You can consume this shared volume to any container within a pod. As you know, pods can have one, but even more containers inside. And there are one or more different types of volumes that can be attached to a pod. The interesting part is if a pod drops, it isn't killed by hand by the administrator, but it has to restart due to any kind of failure. When it restarts, the content of the volume survived and is remounted so that your pod can continue the working with the data inside that volume. But that's the only persistence. It's not intended for longer term. And how the rescheduling support is done, or if it is done, that is support is depending on the volume type. So not every hosting system, not every cloud environment does it the same way. So here you have to take care. The pages on the Kubernetes website are describing for each individual type or for each individual environment how this support looks like. And here you see which volume types are available. There are so many. It's just simple empty directory. You find it in the left, almost at the bottom, and or if you are in Amazon, you have an AWS Elastic Block Store, or on Google, the GCE persistent disk. So there are so many different ways on how to do it. NFS from any NFS server outside, which is reachable by or bound into Kubernetes. You have different ways on provide volumes to your system. And when you deploy a pod, there are two parts that are important here. That is, so they are both inside the spec, but one is a own section, the section volumes, where you declare and specify the whole volumes. So here, for example, it's the volume, the only one volume HTML, which is an empty directory. Okay, once again had trouble with my. I hope you can understand me. Carl, could you?
Yes, now it works again.
If you get me, no. I don't know why it is.
But we can hear you now.
Now, okay. It's ugly with those things. So I want to jump back. So besides having one with type empty dir, you can have others with the type host path or others with the type, let's say, if you're running in Google, the GCA persistent disk. So it's no problem to have multiple of them. And then inside your containers, that's the first part here in the spec session, there you have, in this case, two different containers, and both mount the same volumes. So you have only one volume declared, but you use multiple of them. One for the nginx container, which is intended for the representation of the content, and the other one is the content one, which is only running an endless loop to fetch the data. Oh, no, it's writing. In this case, it's only writing the data, creating kind of semi-dynamic index HTML. So yeah, but you also could, in this loop, let's say every 5 minutes, fetch the whole content from a different repository or similar. So that's a very simple solution. And in this case, you really don't need a larger persistent solution, because when it's restarting, you even could start with an empty directory and the content is fetched. Good. Let's come to the larger parts, the persistent volumes and persistent volume claims. Both are kind of pairs. The persistent volume claims later have still a second kind of usage, but mostly you see those two, and that's how they have been invented in the past as the pair. The idea is that the persistent volume is something that is cloud-wide defined, specified by the cluster administrator. That's nothing that has to be done by or can be done by anyone in your cluster environment, not by any user, but by the cluster administrators with their special rights, because they have all the knowledge and or should have the knowledge and the overview of the storage environments that your cluster provides, that can be used, and how they are used, and which user will use them. So there will be a kind of organization in the company. Also, they know here see again, they have a lot of storage, different storage provider, NFS, GCE once again, RBD, which is by Ceph. There's also a page, I've got added a short URL. There's a page at the Kubernetes documentation where you can see which many types there are. And these are provisioned by the administrators so that they are best way provisioned. And their life cycle is handled totally independently from a pod. So they are existing even without any pod using them. And when all pods which before used them aren't existing anymore, for example, they can be dropped automatically or manually. And they cannot be attached to a pod directly. So if I create a wonderful, fast, persistent volume and call it fast, then any pod user or anyone who creates a spec of a pod and wants to deploy it can't directly use this volume I created. This has to be done with a persistent volume claim. So this will be shown next. And the persistent volume claim, this is something that the user, who is also responsible for the pods, is declaring or specifying. It is other than the volumes, which are cluster-wide. They are namespace bound. So if I say I need a volume which is fast in namespace development, then that's the claim inside development. The graphic will show it. And in this persistent volume claim, I don't say I need exactly this volume. What I say is, from my administrator, I know there are some let's say classes, keywords, filters. There are metadata that help me to describe my requirements, and also surely the size. So I can have multiple matching volumes, but only, let's say, one, for example, has the according size. Let's say I have a 50 gig volume and I have a 200 gig volume, and I want to have in my claim 100 gigabytes. Then the system should not use the 51, but the 201 is okay because it has the size 100 gig and even more. So I satisfy, I describe inside this claim what I want to have and not exactly which volume I want to have. And so this way it is already decoupled, and the same persistent volume claim can work if the administrator, for example, changes the backend of the whole storage types of the volumes from type A to type B. Let's say you started in your cluster with NFS, but now you are moving to a vSphere environment and have the storage there. So this is something you can still do. Yeah. So once again, the persistent volume claims are used by the cluster users. But here, yeah, the word cluster users you have to take with care. It's sure not all people, not the end user is writing the specs, but you know the different person than the administrator. So here the process that is that as an admin, I know in our environment, we currently have 2 namespaces, which I'm not caring for, but I know there is needed for different volumes. The best one, fastest one is called Gold by me, and has a size 100 gigabytes. The not so really fast one is called Silver, and the third one is called Bronze, and it's the slowest one, but it has a lot of space. So that's my part as the administrator. And now next part is that the user says in his persistent volume, in his pods, in his pod specs, that he wants to deploy, in this case, for example, a web and a database pod, both in both environments. So in the prod environment and in the dev environment. It's, as you know, they can have the same name because the namespace is coordinating that. But how now this is the access specified? This is what I've said before, the persistent volume claim. That is that I, as a user, so on the right side, say for my individual pod, I claim the volumes. And this is here, that is written next spec. I will show you in a few minutes. And so, for example, I create a persistent volume claim for the web, and should be 10 gigs and the class Silver, because my administrator told me I should use class Silver here. And for the database instead, I don't need 100 gig, but I need 50 gigs. So the 100 gig is large enough, but I need speed, so I take the class Gold. And for the web on the development side, it's pretty similar. I have the same sizes also for the database, but I will use in both cases slower types, slower classes. So I say class Bronze for my web, and here you get a trouble. I will show you why. I want to have for the database 15 gigs for silver. And if you now take a look, in the first moment, you could think that the 10 gigs of the web in production namespace and the 15 gigs of database in development namespace both easily match on the persistent volume silver because it's 200 gigs, but it doesn't work. Once you have got an assignment between a persistent volume and a persistent volume claim, it is exclusive. So it's not possible that multiple claims access the same persistent volume, that meant then inside of it, for example, in different directories. Here, the administrator would have to create another persistent volume. The requested sizes only mean you want to have the minimum of this size, but it isn't so that you have the possibility to simply, for example, only create one volume or two volumes and let all the different claims then take these. Here we have later a different solution that allows. So when I, as administrator, create a persistent volume, here I do the specification of the system or of the volume itself, starting, for example, with the capacity of the storage, in this case, 15 gigabytes. How the persistent volume will provide the system as a file system or as a block system. These are the two only modes I can choose. I have three different access modes that I, as a volume, support that have to match later the persistent volume claims. At least those have been in parts inside the access modes of the volume. The 3.1 or read-write ones, which means only one can claim it and write to it. Oh, now I've got to think if there is a little something by me. Yeah, I've got to think about it. Read only many means that many can mount and read from it. And read-write many means that even many can write to it, but the application has to take care for the whole synchronization. I've got to think about it. So what do you see here? The persistent, on the right side, the persistent volume reclaim policy, which this is here delete, which means I've got it on the next slide. If the volume shall be deleted once that the PVCs have also been deleted, or if should we retain is the other value. If the volume shall stay and the administrator has to, for example, delete it manually after a kind of archiving backup. There are different ways to do it. The storage class name that is in the example above here, the class. And the name is optional, so it doesn't has to be specified. Then only something like the storage are matching, and the access modes are matching. And then also you have mount options that are depending on the backend system for where you are getting your storage from. In this case here, you see it's an NFS. I don't know if you can see, I can't show you. It's the NFS and with the path exports on the given server, and the mount options for the NFS are hard and NFS version 4.1. So that's, for example, a specification of the persistent volume. And there's a lot of options available depending on the exact way how which kind of or which type of persistent volume is chosen. And now I want to claim it, which is a bit more simple. I specify, for example, the access mode, and it has to be a subset of the one that is defined the persistent volume or storage class, which I show later. And so you see that here is read-write once, and it is a subset of our read-write once and read-write many in the persistent volume. So this, for example, would already match. And I'm would like to have my 1 GB of storage, and this is here also easily inside. And I have a storage class name as this optional way, and this is slow. And in this case, it matches. So these two like each other. There's also a different way on how to choose or let the system choose the volumes inside the claims or by the claims. That is selectors. So for the selectors, you, for example, take typical metadata. Here's the label type is host path. And because in the spec we've chosen host path and have a host path, we could also use any other way of name value combination. Most important is that on the persistent volume claims side, there we have a selector, and inside the selector we say match the labels, and the match then we are matching the labels and have type and host path. So it isn't done by storage in this case, or by storage class. It is done by the labels, but still storage has to match, and the access mode has to match the provided access mode. Otherwise, when we have chosen a persistent volume, having a technology or support doesn't supporting a technology used by the access mode or by the claimed access mode, then would get in trouble. Also, yes, here's once again with highlighted. These two are the interesting pair. And here you see the 4 phases of a persistent volume. And when I've created it, it is ready and it is available to be consumed by those different persistent volume claims. It has the status bound when it has been bound to a claim. And that's a part of what I've said with the graphic of where the red-lined claim hasn't been possible because it is already claimed. Then released. This means that the binding PVC has been deleted. So none is wanting to have the persistent volume anymore, and it can be reclaimed or it can be deleted by the administrator. And then the last part, which we don't want to have, is a kind of error state. Surely each system can have an error, and yeah, there we have, for example, one, and the system stay in the error state because a reclaim doesn't work. So, and as I promised in the beginning, it all can be a bit more convenient. There's a more simple way, not on the side of the persistent volume claims. I still use them as the technology to say for my pod, for my deployment, this is what I want to have as volumes, but the way how to provide it dynamically. And this depends on the backend technology providing storage classes. So these storage classes, there are an abstraction on top of an external storage. So yeah, there is a way of the API to talk to them and dynamically create volumes and drop volumes. They work hand in hand with the system. So instead of having an administrator provisioning storage, this API do it, the storage classes do it. And so the cluster admin isn't needed for the pre-provisioning of volumes. And that's more simple. In the moment I have got a claim, I directly can get it by a storage class. And this is shown here. In phase 1, the persistent volume claim has a request to a storage class named, in this case, standard. I hope the next one shows standard, yes. And the request then internally is done to the storage class created with the name standard. This has to be done by the administrator before, so not yet not for this persistent volume claim, but in general, because the class with all its parameters configure the technology behind it, what the what the system, what your environment, for example, at Google, at Amazon, at Azure are used on your local Kubernetes cluster. And so you have the storage classes there. And now you have a claim against this storage class. The storage class uses its API to talk to the external storage system and to say, here, for example, I need, with this class standard, I need 10 gigabyte. And here in this case, you get exactly 10 gigabytes because then this volume with exact 10 gigabytes is provisioned on the external storage system. And that's here in point 3. The external storage system creates a PV strictly satisfying the PVC request. And the PVC then gets this wonderful name, which is the UID of the PVC plus a prefix PVC, but it is a volume, so it's you have to see the column after the PV and the blank. So if you in this moment let kubectl show you the persistent volumes, you see this new persistent volume. And then this persistent volume is mounted to your persistent volume claim. So this is a kind of circle, quite simple, dynamic, and but surely once again with standards like reclaiming or like deleting and stuff like that. But as mentioned, you get dynamically this volume, and you have it dynamically in your right size and get it mounted. So here, for example, I've got a storage class. It is the name standard as we had shown here. I can have also other ones with other names. Important is that I specify provisioner, and in this case I'm on Google, and yeah, I've PD standard. The standard is the non-SSI type, and I'm in the US central data center A and B, and my reclaim policy is delete. So in the moment my UID 9DF65 and so on is dropped. This whole storage class is dropped too, or not the storage class itself, but the claimed volume is dropped and deleted. So yes, that's the storage class. And so it's by far more simple this way. And also here, as you can see, there are several ways on how to provide it. All these can once again be read in the Kubernetes website and in the documentation, how there's a difference, and they are supporting different parts and others support not. And so, or it depends on if you are, for example, or where your cloud is, your cluster is running. Yeah, you can choose. Okay, that's the main part about volumes and storage on Kubernetes.
Okay, thank you, Frank, for the dive into how to keep the state of your apps and persistence. As far as I can see, there are no questions in the chat, but maybe you still have some which you would like to ask now. Okay, no questions. If there still should come up some questions to your mind later on, which you maybe don't want to ask here at the moment or whatever, you can send us an email to marketing@kubermatic.com, or you can reach out to Frank to go through your questions and open topics with him directly. But yeah, so thank you very much for joining. I hope you enjoyed it and that you could learn something in the session. Just very short on our own behalf, I think you all might know that next week KubeCon Virtual 2.0 will hit off. We'll be there. We'll be available at our online booth from November 17th until 20 from 6 p.m. So if you want to get some more insights about the new features of Kubermatic Kubernetes Platform 2.15, or if you just want to keep up to date about the latest product announcements, or if you just want to chat with us about Kubernetes or cloud native related topics, come by our booth. We'll be happy to see some of you around and to get an exchange with you. And of course, we are always happy about new followers on Twitter or about new GitHub stars for our open source projects. So support is highly appreciated. Yeah, so that's it for tonight. Thank you very much for joining. And I hope to see you all soon again next time. Bye.
Bye-bye.